Right. Good morning, everyone. How are you today?
Good morning.
Casey, I hope you're getting the audio now. It wasn't that there wasn't any audio, it was that I wasn't speaking yet.
Morning.
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 Morning. As you're also chatty and also keen to get involved today, maybe we can do something a wee bit different this week. Last week you all kept your cameras off, and I felt a bit as though I was speaking into the void. If you've got a camera and you want to turn it on, why not turn it on, and we can at least feel as if we're in the same place even when we're not. He says,
Something
looking
like
at the
this.
screen, and nobody turning it up. There's one. Good morning, Rami.
Doesn't seem to be working for me.
Morning.
Morning.
Morning all.
Morning.
Some people don't have one. Fair enough.
I tried turning my on, but it's just black. Like it just doesn't show anything.
Yeah, I'm sitting at a window.
I love that Pablo said that his camera's microphone is terrible. That's not how video works, Pablo. But never mind. Oh, Andrew's a man of mystery.
Oh, I know, it's right at a window.
Don't worry about it. Don't worry about it.
Yeah.
Excuse me. So, how are we all today? This fine morning.
I woke up
All
about
good
what,
here
10 minutes ago.
at work.
You woke up a few minutes ago. You mean you didn't have your alarm set for 8 o'clock, ready to come in and chat? Goodness.
Oh no, I did, but I just slept through it.
Jen's all set with her cup of tea. She watched the video last week. Excellent. Vegan, yes, absolutely. Man, this is weird. A weekend, finally seen some of you at last. Yeah, I'm beginning to regret this, asking you to turn on the camera part. Maybe it was a mistake.
I don't know what's happening with mine. It just won't turn on.
Have you tried turning it off and on again?
Multiple times, David. I work at technical support. That's what I do.
You guys have definitely got a
That's not a
future.
good start then.
Okay. Welcome to today's lab. Lab? I'm going back to my bed. Welcome to today's lecture.
We can make it a lab if you want.
No,
Just
we'll
one
do that.
question, Tony, before
Yeah.
we start.
Yeah.
Is that business attire like from the waist up?
You'll never know.
Okay.
God.
That answers that question then.
I'm saying nothing. You're never going to know if I've got my pajamas on underneath this shirt and tie. Okay, the reason I said lab, he says covering, is because I put some assignments up. Some of you were chatting last week, asking where to upload your thing from the lab this week. Because it was the first one, I wasn't really that bothered about you uploading it. It was some fairly simple stuff. But you'll have seen during the week that I set up some assignments in Teams. So there are places to upload last week's lab. The one for last week, you can upload it or not as the mood takes you. It's not mandatory. But from this week on, we will start asking you to upload them, okay? Just to make sure that you're keeping up. So if we get to next week, so all of the assignments on Teams will have a deadline of 10 a.m. next week. So if I get to next week and you haven't uploaded the lab for this week, we'll have a chat during the lab time, okay? Because I want to make sure that you're keeping up. It's so much easier if you do a wee bit every week. I said this last week. If you fall behind, it becomes difficult and tricky. Speaking of which, any questions from last week?
Tony,
All good here.
I've got a question for you.
Yeah.
I tried to, I had a wee look at, I was trying to look at your videos from last week and they jump about quite a bit. The videos
Jump
1, 2,
about in
3.
what sense?
Video 1 finishes at a point in Python where you've just started looking at it, and then video 2.
Oh, yeah, Andrew, you're new
It's-
this
'cause I
week,
was, yeah, I'm new. I wasn't here last week, so this is
Yeah.
my first.
we had some slight technical issues last week. Jennifer Watson broke it all as we were going through it. And that's why there wouldn't be 3. So hopefully this week there will be 1 video
Right,
in it for the whole
okay.
thing.
Aye.
But last week, can I even remember what happened? We did something and it stopped recording.
It's
And
because you swapped rooms to go get the other
Swap
people.
rooms.
oh, that's what it was. Yeah. Some people had gone to the lab instead of the lecture. I went there, and apparently that kills the recording. We didn't notice till 20 minutes in or something. So
that
yeah,
would
that's what
explain
it was. It's not anything you're doing wrong, Andrew. It is just
Right.
the way it happened. So my apologies.
So,
Oh,
will
we've
it,
got a new
will it be
member.
easy, will it
Excellent
be
job.
easy enough? Will it be easy enough to catch up on though?
Yeah.
Mhm.
Go through the slides, which are still on Teams. You get access to Owler yet? They should be on Owler, but I don't even know if that's available. I can't get access to it. But last week's lecture and lab are on Teams. Go through there, work your way through them, and if you've got any issues, give us a shout in the labs, Andrew. So
Right,
there'll
no
be
worries.
at least 3 of us in the lab, myself, Enrique and Pablo, and we're available. And if you want a chat, we can either do it sort of in public like this with everybody there, or we can go and grab a separate personal chat if you want to catch up on. But
Nah, that's
it's
fine.
week 1 and it was deliberately a very basic introduction. I think we
Uh-huh.
spent more time watching Python videos than we did anything else. So,
So I missed something then, yeah. Miss watching videos. Cheers, Tony.
thank you for the link. Yeah, I've got the link, but half the stuff doesn't seem to be there. Gelco, is that how you pronounce it? I'm going to get a lot of these things wrong, so apologies in advance. Oh, excellent. So yeah, I have the link, thank you, but some of the things, just you click on them, there's nothing there and they're not connected yet. Seem to have issues. Once you upload the assignment, could you re-upload the same assignment before the end of the deadline? As far as I know, you can. I will be honest, it is the first time I've used Teams for this. Last year we used Moodle and I understood pretty much everything about Moodle. I think I said to you last week, I said to you last Wednesday, I get access to Owler the day before. So we had our lecture 10 Wednesday, I get access to Owler 3 p.m. Tuesday. So I know very little about it. That's why the things are on Teams and I don't really know. As far as I know, it will let you overwrite. If it doesn't let you know, maybe there's a setting, because I'm happy if you want to
hand it
overwrite.
in, and then you can undo the hand in. So until the deadline, you can undo the hand in and then replace the files that you gave in and re-upload it. That's yeah, you can do that.
Okay, thank you. I actually deliberately left it so that you could hand it in after the deadline, partly because last week I'd said I wasn't looking for a hand in, but some of you wanted a place to put it. Don't see any other questions in the chat. So for those of you that weren't here last week and weren't looking at that rather wonderful video, a couple of ways of getting my attention. Stick your hand up. So at the top of the bar, there's a wee hand. Hit that and I'll see if people have got their hand up and want to ask. Or put a Q into the chat. If you're working on a PC or a Mac, you can actually keep the chat window open, which is quite good fun because everybody's chatting away while I'm talking, you know, when you're supposed to be paying attention to me, but that's fine. Just chat, see if I care. So keep the chat open and there's other things happening in there. You can see the questions, you can see the answers, and we're all helping out each other because someone's just asked about the 3 Python files in a zip. Yeah, that's fine. Either an zip or just one big text file is actually the simplest way to do it. Later on, we'll get something a bit more formal, but at the moment we're creating small programs, and all we need is a wee bit of text. Okay, so any other questions before we launch into the lecture? Nope, I'm not seeing any hands. I'm not seeing any questions in the chat that I haven't answered yet. I'm hoping you're seeing the lecture. If you're not, let me know. But let's move on to talking a wee bit about data and variables. Before we do that, a quick recap of last week. We did some text, we did some numbers last week, and basically we displayed them on the screen, which in Python speak is print. As far as it's concerned, anything that's displayed, whether it's a printer, whether it's a screen, whether it's wherever, is printing. And I asked you to do some things in the lab last week, and here's a couple of possible solutions. So you can have multiple print statements if you want to print multiple things, but some of you found this, and if you didn't, this thing here, it's called a control character. So anytime in a string you have a backslash, that's a control character. Anybody want to take a shot at what N might stand for?
New line.
New line.
New line.
New line, next line, whatever, yeah. So it prints your mother was a hamster, takes a new line, and then continues on with the rest of it. So there's a few of those things, and we'll cover them in the coming lectures. So like backslash T would be tab, for example. That's going to be a recurring theme. There's quite often multiple ways of doing things. Oh, and I should say, again, for those of you that weren't here last week, I've got 3 screens here. So when my face is like that, I'm looking at you guys and I'm looking at the chat. And when my face is like that, I'm looking at the presentation that you can see. And when I'm looking at that, it's me controlling everything from my middle screen. So I'm not watching tennis. I'm just trying to keep track of everything that's going on. So apologies if it's distracting. Okay. So either take multiple prints or put in some control characters in the text. So that was the text one. The other one was about numbers, and most of you managed to get that. We had some calculations, and in almost all programming languages, plus and minus are obvious. Multiply is the asterisk, and slash is divide. Yep, triple monitor, Nicholas. Suck it.
Sir, do we have to type in the first 2 lines? Because when I done mine from last week, I just typed in the 3rd line.
I'm more interested in the 3rd line. It was the 3rd line where you're doing the calculation that I'm actually wanting you to do. Because
Perfect.
Clearly, if you've done the first one, you know how to type in print and put some text in it. So no, I'm not really that worried about that bit.
Absolutely. You're basically concerned of the result, how you get the result of the question. Perfect.
Yeah.
But you can add this as a text though to explain what you're doing. So you add like 2 slashes to make it a text to explain what you're doing.
Yes, you can. And we'll talk more about that later. Because one of the things I want you to do is comment your text, comment your programs. So with things like that are comments in a Python program and in quite a lot of other types of program as well. So yes, we are going to talk about commenting because it's something you should be doing all the time. But again,
Because
all
it
the-
makes then the code easier for anybody that's gonna be reading it. For example, if you're in a company later on, or etc. etc. So everybody knows, right? This is for that. So it's easier to access and be seen and be changeable.
correct. And you're saying for other people, and I can tell you from bitter experience that it's not just other people, it's you, because you might write some code, you go away for a month, and you come back, and I can tell you it might as well have been written from someone else, because it's just as hard to understand your own code when you're coming back to it and it's not commented as it is to understand someone else's.
True.
So comments are good. How do you remove the space from the 13 on the line? We'll get a whole lecture on that. I think it's lecture 4. So we will be doing a whole lot of formatting things. So if you don't mind, we won't do it just now. But if you are really interested, Google text processing on Python, and there's loads of tutorials out there, but I promise you we will get to it in a couple of weeks' time. But for the moment, what I wanted you to do was this bit and make sure that you could do some calculations. So 5 asterisk 2 is 5 times 2, and plus the 3 gives you your 13. Now, you notice that there's also brackets around some of it. In this particular case, it doesn't matter. If I say BODMAS or BOMDAS, does that mean something to you?
Yeah.
Yeah, some of you, I'm
Understand.
seeing some people nodding, some people shaking their
Yeah,
head.
it's like brackets before additions or anything else.
Yep,
Order
it's
of
the
operation.
order. Say that again, sorry?
Order of operation.
Absolutely. It's the order that things happen in an arithmetic expression. So when you're doing things, you do BODMAS. Thank you, Chloe. I was just about to type that in. Excellent. You do everything in brackets before you do, I learned it as of rather than order, but okay. Then you do the divide, the multiply, the add and subtract in that order. Actually, it doesn't matter if you do the multiply before the divide or the subtract before the add, interchangeable, which is why I said BODMAS or BOMDAS. Some people learn it differently. The point is, however, there is an order, and that's the order that Python will use. So if you want something else, use the B, use the brackets part to make sure that it works the way you want it to work. Okay, so last week we saw a couple of, come on, you can do it. There we go. Last week we saw a couple of different types of data. We saw text and numbers. Text was in quotes, numbers weren't, and we printed them both out. But just like with every other programming language, there's a whole bunch of other what we call data types. So data is information, numbers, text, whatever it happens to be. But there are different types of them. And they work in different ways. Again, anybody want to take a stab at what an integer is?
Isn't that a whole number?
A whole number. As opposed to?
Like a point?
It's a number with decimal.
So 1, 2, 3 is an integer. 1.23 is a floating point because there's a decimal point in it. A string we did last week. Does anyone know what a Boolean is?
It prints out true or false.
1, 0.
And I like Hubert's because yes, no, because I asked the question in a Boolean way. Does anyone know
It
what
prints out
Boolean
if the
is?
statement
Yes
is
or-
true or false.
Yep, we heard you, Rami. It's okay.
Thanks.
But I'm saying there's different ways of saying it. So there's true and false, 1 and 0, yes and no. It's something where it's one thing or the other. And again, if you did computer systems or your college equivalent, you'll have come across Boolean before. Now, it's important that we understand these because we have to work with data, and it's important that we work with it properly. We saw last week what happened if we tried to combine things. If we have a Boolean, which is true, false, what is the answer to 1.23 plus false? Yeah, no wonder you're all looking confused, because there isn't an answer. So when we have our data types, it's important to understand what they are. Joseph, you're quite right, you would get an error. We have to know what they are, we have to know how they would work so that we can work with them together. So Python tries to help us out. We have functions. So remember last week, we have pre-built functions that we can use. So print comes with Python, and if we use it, we can print out things onto the screen. All of our functions have whatever they're working on in brackets. So here we've got something else. We've got print bracket, type bracket, 37, close bracket, close bracket. In other words, this type bracket, close bracket, is another function. So we can see that from the way it's laid out. So we have one function, print, and what it's going to print out is the result of a second function, in this case, the type function. Sometimes, as ever, these things are easier to see than to explain. So here's our text from last week. Once it catches up on itself. Come on. Go. Okay, so here is what we did last week. We did things like this, print 37. And then we could run it. And the results were down here. So the result of that program is just to type out 37. Again, I know you guys were here last week, some people weren't, so I'm just covering some things that we did last week. But what is 37? Which of these data types is it? Well, we can ask Python to tell us. We can use the type function to tell us what type the data is. And it tells us it's an int or an integer. Zero is also an integer. Minus 13, also an integer. And I want to take a shot at what that will be when I run this.
Float.
Well done. It's a float. Floats can also be negative. And one of the things that you need to be sure of is how big and how small your numbers can be. It's called the range of a number. And that's also encoded in the data type. And the reason you need to be careful is that if your numbers get too big, they overflow. If they get too small, they overflow, which is a technical term for getting to the end and starting at the beginning again. So with a computer, you count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you reach its limit, depending on what its limit is. So if you only have 8 bits, its limit is 255. And in an 8-bit computer, if you add 1 to 255, you don't get 256, you get 0. The computers we're using clearly aren't 8-bit, but the same thing will happen. So if you've got very big numbers or very small numbers, they can cause huge errors. There was a famous case of a probe that was sent to Mars. It missed by about 2 million miles because the numbers overflowed and they got the calculations wrong. And the one that we didn't see last week, oops, helps if I'm on the right screen. The one we didn't see last week is Boolean. Now, as we said earlier, it could be true, false, 0, 1, yes, no. Python actually uses true and false. So true is class Boolean. As I say, we've got true and we've got false. Oh, apparently we don't have false.
Capitalization.
You want to expand on that?
False is not capital.
Capital.
Yeah, it needs to be in cap. I tried false with small letters and it didn't work, so I was thinking it was different, but I tried it with capital and it worked.
So why do we care?
Well,
Because if you don't write it accurately, it will not print out the result that you're looking for.
Because Python
So
cares.
false, pardon?
Because Python cares.
Yeah, that's actually quite a good way of putting it. I don't know if you noticed that there, the colour changed. So it went from false, all lowercase. Python thinks that's a variable, which we'll talk about shortly. Capital F, and suddenly it goes blue the same way as print is. It knows what it is. So again, remember, in Python, an uppercase is not the same as a lowercase. And even though you know what you mean, Python doesn't. No programming language does. But if I change that back to capital F, we are fine. Okay, so we've got different data types. Everyone happy with that? Okay, so we have floating points, strings, booleans. And if we're not sure what we have, we can use type to tell us. And that can be really important because sometimes we want something called a variable. You that added up numbers and multiplied numbers and did things with numbers, but you used those numbers and you wrote them into the program, which is fine as far as it goes. But normally what you want to do is choose your numbers. If you bought a calculator that could only add up 5 and 6, it wouldn't be really helpful. you kind of want to enter the numbers that you want to add up into the calculator. So for Python, we have to set up something where we can change what the numbers are. And another word for change is variable. So all programming languages let you set up variables. What do I mean by that? Well, do you want to take a shot at what we're doing here?
Is that not basically where you are declaring what num1, num2, num3 is, and then you're saying, okay, the answer, I want num1 plus num2 plus num3, and then it will just print out the total is the answer, which is basically the addition of all what 1, 2, 3 is. So basically 2, 3, and 7, it will print it out automatically.
12, yeah.
In a variable.
Yes, basically. So we are declaring a variable, the first number. We're giving it a value. Now, I want, right from day one, I want you to know the language. How would you normally say that line?
Num1 equals 6.
And I do not want you to say that, please. Because at the moment, num1 doesn't equal anything. What we are doing is actually saying what num1 is. So when you see that, I want you to say not equals, but becomes. Num1 becomes 6. Okay, we are setting the variable num1 to be 6. Equals is different. Equals is saying is something equal to something else. And actually, we will do that, and we'll have to do that later on when we're programming. At the moment, we're not doing that. We're not checking if something's equal. We are assigning something. So please start to think in your head, not num1 equals 6, but num1 becomes 6. Num2 becomes 3. Num3 becomes 4. Okay. And then we can do whatever we want with them. Answer. We've just set up another variable. So we've got our first 3 variables, num1, num2, num3, and we're going to set up another variable called answer. What's the value of answer at the moment?
Nothing.
Nothing.
Nothing? Any
It's just a
advance?
bit of text.
Just a bit of text? The answer is, don't know. What's happening here is the computer is taking a space in memory. We don't know what that space in memory was used for before. It could have been that line of text where we said print 37. We just don't know. So we don't know what that value is. It's not automatically set to 0. It's not automatically set to nothing. We just don't know yet. The only thing we know is that we now have a variable called answer. So we need to set the value. Answer becomes num1 plus num2 plus num3. And then we'll use our things from last week to print the answer. Before I run it, anybody want to say what the answer is going to be?
$13.
13. Thank you, Nicholas. Thank you, Chloe. Thank you, Andre. Thank you, Andrew. Okay. Before I run this, what's the answer going to be?
$36.
36, 40, 18. Somebody's using your calculator, that's cheating. No point bringing up the calculator and putting it in
18.
front of the camera.
18.
18.
18, yeah.
6.
Yeah, 18.
Remember what was it, Chloe? I can't remember. Yep, remember what Chloe said at 10:24. Brackets, order, divide, multiply, add, subtract. The order is do the multiply before we do the add. So we do the num2 multiplied by num3. So 3 times 4 is 12, and then we add the 6. So those of you that said 18 are quite right. And when I said 10 minutes ago that quite often we use brackets to make it clear what we want to happen, that's why. Because that's sometimes not very clear. But if I modify that, like that, it's very clear. We know what's going to happen. Average, we don't need brackets. That's the thing. Brackets make it clear if you're not sure of the rules, but we don't need them because Python will follow the rules, the BODMAS rules.
If you want it to be 36, you would need brackets.
If you wanted to change it, if you wanted it to be that, you want to add num1 plus 2, so 6 plus 3, giving you 9, multiplied by num3, which is 4, which is 36. As you quite rightly say, then you need the brackets if you want to override the order. So just be careful with how you set up the numbers. Everyone happy with that before I move on? Everyone see what's happening here? Yeah.
Yep.
I'm not seeing any questions in the chat either, so I'm assuming you're all
All good.
cool with that. Okay. So, I mean, that's great. And we got an answer, but actually we're not really any further forward. We've just added in more text and variables and stuff. What we need to do is make this more useful. And the way we're going to do that is to use yet another function. So instead of in the program assigning, instead of saying input, instead of saying num1 becomes 6, I'm going to use another function called input. Input is going to do this.
Wait, why does the input thing need brackets and the num1 does not need brackets? Or num2?
Well, I've only changed num1 just now. Num2 is exactly as it was. So I'm just doing num1 just now just to demonstrate. Except clearly I've got it wrong. It didn't work like that. It's the first time that we brackets around it, called the function, used brackets, and it's saying name num1 is not defined. Bummer.
I mean, you replaced num1, didn't you?
How do you mean replaced?
You took num1 equals 1 and replaced it with input is num1, but like like num1, the definition of num1, which was 1 or 4, whatever it was. I forgot what it was you took away.
Firstly, not num1 equals, num1 becomes. Secondly, while that's true, it's also true in line 2 and line 3 because they don't exist there either until I say they exist. And that's one of the things about Python. There are some languages where you have to do what's called pre-declaration. You need to say, I am going to have a variable, it's going to be called this, and it's going to be an integer, for example. Python doesn't need you to do that. It instead, when it comes across a variable name, says, oh, you want to use a new variable? Fine, I'll add it to the list. Which it's done quite happily for num2 and num3, and indeed for answer. So, how are we going to change this? What's wrong? Well, the answer. Sorry?
Sorry, I was going to say you need to find number1 then with a number, numeric or integer.
No, it's slightly different. It's simply that input doesn't work like that. What do I mean? I mean that if I do a search for Python input function, I have no idea if this is a good link or not, it's just the first one that popped up. Input is a function used to get input from the user. Go away. No, you do not have my consent. Beat it. Python is a function used to get input from the user. It prompts for the user input and reads a line. After reading data, it converts it into a string and returns that. It throws an error if EOF is read. Oh man. We need num1 instead of num1, where num1 is in quotes. Right, okay, let's read this through and see what it means. I'll see if we can understand what it means. Because one of the things you're going to do as you're going through this is come across pages like this. But it tell you what a function is and how you're going to use it. So, input is a function to get input from the user, fine. It's fairly clear from the name. It prompts for the user input. Now, prompt is a name that programming languages use to say, give me something. It's what appears on the screen. Enter your name here. Enter the value here. So it's looking for a prompt, which might give us a clue as to why it didn't work. The format is input prompt, and the prompt is a string message, which prompts for the user input. So I just put the number in there. I had put what I was hoping was going to be the answer, num1, which I was wanting as a number. But that's not how this works. It's looking for a string. So I suppose we should put something in that's helpful. Okay. Great, so we've looked up the input function, we have prompted for it, and we're good to go, yeah? Okay,
No.
Let's run, see what happens. When you go.
Well, once you've entered the number, you still don't have a num1 in the answer.
Ahead of me as ever, Jen. So we've got the prompt up. It says enter number. I've entered a number. I've hit enter. And we've got another error. Name num1 is not defined. Jen, tell them what that means, seeing as how you were there first.
Because you took away num1, so there's no, num1 has not become anything.
So num1 is there in the answer part, but we don't have it up here because I took it away because we're getting the input. So how are we going to assign num1? Harpreet has got it in there in the chat. We are going to say, as we did before, num1 becomes, because that's the other thing about the input function, it has a return. In other words, it's a function that doesn't just do something, it returns something. So the function we've looked at before, like print, just displays something. But this one gives you an answer. It returns the user input to the number. Excellent. So we say num1 becomes input enter number. Okay, all happy now. We've got 3 numbers. They're going to be combined. We're going to get an answer. Yep. All happy? Ready to run? I heard an but nothing else.
I mean, I tried it on my program, but it didn't work.
Did it not? Oh, man. I keep getting this wrong, don't I? Yeah, thanks, Chloe. Type error must be str, not int. Okay, so str is
String.
Is it not a string?
because, again, I didn't read this properly. It returns a user input after converting into a string. And I can prove that. I can print the type of num1 . I'm entering 8, which looks like a number to me, but it tells me that it's class str. It's a string. So there's one last thing we have to do. We need to change what we've got from a string to an integer. And as Jack points out, we've got another function to do that. As well as having the input function, we can add the int function. What that does is it takes the input and then makes it into an integer. We could have done it in 2 different inputs, but we'd have had to set up 2 variables. So we'll just do it like this. So it's going to ask for the input, I'll enter the string, and then int is going to do what we call cast. It's going to cast it as an integer. So we'll run it again. Still asking for the number, still entering 8. Now it's an integer and it gives me a number. Fantastic. Indeed, Chloe.
Wait.
Yay.
I mean, if you entered like string values, like say you typed 9 as a word, like what sort of error would it give you then? Because I mean, it's trying to cast it as an integer.
So if I said something like 8 as a string, was that the question?
Yeah, something like that.
Okay, let's see what happens. Invalid literal for int with base 10, 8. Wow. So what's happened here? Well, does anybody want to explain what's happened here?
I mean, I guess it was trying to find something that it is able to translate as an integer, but anything, so gave that.
Kind of. Remember what input does. It's taking a string. And as part of that string, I've entered a string. And there's a clue here because there's two quotes. So it's got quotes inside a quote, which brings us up to another question. How do we get a quote into a string? In other words, what if what I wanted to print was a quote mark? Python's going to get very confused because it's going to see the first quote mark and say this is a string. It's going to see the second quote mark and go, oh good, the string's finished. And then it's going to see a third quote mark and go, what? And it's going to complain. So there's ways that we can get quote marks into strings using the same kind of control characters that you saw earlier with \n. But what's happening here is I've put the quotes in and it's got multiple quotes and it's thoroughly confused. It's got, instead of a string 8, it's got quote 8, quote, which it can't convert into a number.
So if you wrote the number 8, E-I-G-H-T, I think is what Nicholas meant, would it give you the same value, same error as that, or it would just tell you it's not an integer?
Do you want to take a shot at what would happen?
Same thing, no?
Same thing?
Same error.
Same error?
I don't think so, because what like the error was last time.
I tried.
Same error, but with a different reason. Invalid literal, because it can't convert the characters E-I-G-H-T into a number 8. So there are only certain characters that it can take. Not surprisingly, it can take numbers, but it can also take dots because that makes it a floating point number. So why did it still fail?
Because we were trying to push it into an integer, which 8.8 isn't.
If we wanted that to work, it wouldn't be an int, it would be a float.
Would 8 without a decimal work in float?
What do we think? Would 8 without a decimal point work in float?
No.
So you would have to write
Yeah.
8.0.
I think it'll work.
Right, hands up if you think this is going to work. The virtual hands up. Who thinks this is going to work just with that? Nobody thinks that's going to work? Nobody's put their hand up?
And you're making it sound like it's not going to work. This is a very easy question.
It is absolutely going to work. It will be quite happy with that.
Wow, then why are we using int anyway? Like if float will just work in more cases.
Oh, very good question. One of the reasons is that you might not want a float. How many cans of beans has this person bought? 3.2. What? Wouldn't it be better to say it can either be 3 or it can be 4, and you want to know if it's not?
Ah, okay, that makes a lot of sense. Thanks.
So there are reasons you'll use different data types depending on the problem that you're trying to solve. Having said that, entering 8 without a full stop, it's quite happy to say, yes, that is 8.0. It's the same thing.
Would that work with everything? Would that work with like number 3, number 4, number 5?
You mean if I entered 3 instead of 8?
Yeah.
Or do you mean that?
Yeah. Yeah.
What do you think, will it?
Yeah, I think so.
Yeah, I think you're right. Okay,
Print
so we'll
type
take
number.
that, or we'll take that. Or in fact, it will also take
Yes.
Yeah.
okay, so there are some characters that numbers can have. Hyphens for negative, dots if they're in a float. But other than that, if you put in any kind of character, it will get upset. Enrique's put in the chat about input, which is something I actually didn't know. Input will work in multiple bases. The assumption is that you're working in base 10, but you could work in base 16 for hexadecimal. You could work in base 8 for octal. You could work in base 2 for binary. Don't worry, we're not going to start talking about all those just now, but it just means that there's other options that you can have. So what we're going to do is we're going to go back and we're going to choose int again. And the reason that I did all this, by the way, of course, was to point out all the different ways that this one small line can go wrong. Okay? Dozens of different ways, dozens of different options, and only one of them is exactly what we want. That's not something to be scared of. That's just something to recognize and understand. And that's why I went through all those different options just to try and see what would happen. We can extend this. So at the moment, whoops. At the moment, we are only getting the value of num1 as an input. We could do the same for num2, in which case it will ask us for 2 inputs. And we could extend it to num3 and so on. Why was it minus 1.199999? Because that was the answer, which I realise is a glib statement, but it's true. It was just the answer to the calculation with the numbers that I put in. Isn't minus 3.3 times 3 times 4 minus 1.2? Also a good question. And I realised, Roland, they were both you, which is why I was kind of working backwards. The reason that you get the difference is because of something called... actually, do we want to get into this just now? Probably. Remember I spoke earlier about accuracy and numbers getting really big and really small. There's another problem that we have. We are working in binary. So in binary numbers, it goes 1, 2, 4, 8, 16, 32, and so on. Okay, you're all happy with that?
Yes.
After the decimal point,
Yeah,
say that again, sorry?
no, I was just going to say yeah, because it just doubles.
Yep. To the other side of the decimal point, instead of doubling, it halves. So it goes 1 over 2, 1 over 4, 1 over 8, 1 over 16. 1 over 32. Some of those numbers are fine. 1 over 2 is 0.5. That's fine. 1 over 4 is 0.25. That's fine. What is 1 over 8? 0.125. That's fine too. 1 over 16. Oops. .0625. 1 over 32. 0.03125. You can see the difficulty. As we get smaller, the accuracy becomes more important. So whereas when we double, the number just gets bigger. When we half, the number gets smaller, and at some point, we run out of space. At which point, 1 over 64 might not be 0.015625, but it might be rounded to 0.01563. And that means when you start multiplying or adding or doing anything with them, instead of it working out exactly as 1.2, the errors in each part of the number mean that you get a final error. So instead of it being 1.2, you get 1.1999. It happens in all sorts of places. Have some fun later on by laughing at Microsoft and looking at things like rounding errors in Excel. You've all heard of Excel. It sold millions and millions of copies. This same thing will happen. You can put these sorts of things into Excel and they won't work. 0.01 divided by, what's that, 10 million, gives you the answer 0. Well, it isn't. It's called a rounding error. It happens in every computer, and it's something that you have to watch out for, particularly if you have very big numbers or very small numbers. As an aside, banks use something called BCD, which is called binary coded decimal. Because if you do a rounding error on numbers, somebody gets all the wee bits of money left over. And if it's not you, you get upset. So banks actually encode their numbers in a different way to ensure that these rounding errors don't happen. So this problem happens even though the calculation does not get more accurate than 1 decimal place. Yes, but you're talking about the final answer. The bits in the middle are different. So it's the subcomponents as well. If you use more bits to store the number, will it be more accurate? Yes, it will. And you can choose how accurate you want it by deciding how many bits you want to use to store your number. So a fairly innocuous question with actually quite a profound answer, because it goes to the very heart of how computers work and how they store the data. All from us trying to just get somebody to type in a number. Mohammed, you've got your hand up. Mohammed has got his hand back down. That was presumably a mistake. Okay, so all these things can go wrong. And as I say, part of the reason that I made all those mistakes was to show how easy it is to do them. So don't get discouraged. It can happen. And like I said last week, the ones that I did there, the ones that I just showed you, were deliberate mistakes. So you could see all the ways that things can go wrong. But I do these things not deliberately all the time. So make sure you understand what it is you're doing. Make sure you understand what you expect to come out. Do things like putting in statements like that, so you can understand what's happening as things go through. So add in bits that say print the type, so that you're sure that it's an integer, so that you're sure that it's a floating point, so that you're sure that it's whatever it happens to be. Later on, as we get further into PyCharm, there's different ways of doing that. But right now, you can start debugging, making sure your code's correct by using things like this.
Sir, so for our class, do we need to type in print, type, etc., when we're uploading our answers?
No, what I'm saying is if things are going wrong, you can use techniques like this to try and figure out how to get them to work correctly. And one of the things you need to do that is to know what you expect your output to be, which is part of the reason I asked you what the answer would be earlier. If you didn't know what the proper answer was supposed to be, how can you check whether your program works or not?
True.
So understand what it is you want to do, understand what the output will be, and make sure you get that output. It's simply testing. And in this case, it's testing for a very small thing, but later on we'll start testing on much bigger things. But the same principles apply. Know what you want to do, know what you expect as an output, run your program and check that you get what you expected. That's testing. Any other questions before we move on? Okay, so we've got input, it has a prompt. We can cast it as a variable, cast it as an integer, put it into a variable. And it means that eventually we've got something that we can get input from the user. At the moment it's been integers, but we could do anything we want. We can have float strings, we can have whatever we need. Now you need to be careful, as I pointed out earlier, when we used false, remember I pointed out that when I did that, it was in black, and when I did that, it suddenly changed to blue. And you can see that with some other things, print and int and input. It's because they exist within Python. And sometimes you'll get confused and you'll try to use variables that already exist as keywords in Python. So things that Python already uses. So for variables, we can have them as different types. You can check what type it is by using the type function. Just because you've called a number, just because you've called a variable num1 doesn't mean that it's a if you set it to a string, because computers are stupid. Just because you've said num and in your head that means it's a number doesn't mean the computer knows that. I could quite happily call a variable my float, and in my head I'm setting a floating point number, I can make it anything. Python's stupid, it doesn't care. It makes no connection between your name and what it is. So make sure you understand it, and you can use the type stuff to do that. Remember about upper and lower case. They are different. Now, there's different ways that people do it. Some people use variables as all lowercase, and things that won't change, which we call a constant, they put with an uppercase, so that when we're reading the code, we know whether it's something that will change or something that we're not expecting to change. That's kind of why true and false have uppercase T and F, because true and false aren't going to change. They are always the same. But there's no rule about it. You have to decide. And you have to decide whether you're using banner number there, like that, with 2 uppercase, banner number all in lowercase. Some people will use something like that to split words. So banner underscore NO. And my favorite in looks is camel case. So I would start the variable as lowercase, but if there's another word in it, I would capitalize the first letter of, oops. I would capitalize the first letter of the second word. So banner uppercase NO. You can't use dot lower or dot upper function to change it, because this is your variable name. You can use lower or upper functions for text, not for your variable name. That's for you. And in fact, what you'll find is different programmers, different companies will have different styles. I like camel case. Some people like underscores. And some people will tell you that this is the way it has to be done. And there isn't a this is the way it has to be done. But there is one rule that I will enforce. I don't care if you prefer this or this or this. However, once you've chosen one, stick with it. Don't, in some cases, use camel case, and in other cases, use other underscores. Don't, in some cases, use all the words together, and in other cases, use something else. Decide what your style is and stick with it. And I will mark you down if you swap between them. Thank you, Pablo. On the chat just now, there are style guidelines for Python, which you can read. It's probably worth sticking with, particularly when you're new to programming. But be consistent. If you're creating variables, don't use these, because these are the things that are already in Python. So false, true, none, all these kind of things. You can't start a variable name with a number. Okay, so some rules about how you name variables. Everyone happy with that?
Yes.
This was supposed to be a 1 hour lecture, and it seems to have expanded more than a little. Okay. Finally then, I want to talk a wee bit about operators. And we've looked at these before, so some of them we've already seen. So there's arithmetic. So we've talked about that before. Addition, subtraction, multiplication, division. There are other ones. There are other misspelled ones, Jerry. How do you know what these are? And if not, can you work out what they are from the examples on the right-hand side? So does anyone want to take a stab at modulus?
Percentage is a reminder. Double star is a square root or multiplier.
No,
And the last one is
hang on a second. Let's stick with the first one. What did you think modulus was?
it's a reminder. It's what the
Okay.
operator gives, like how many times 5 goes in num1. And then
So hang on then. So the answer to that in that case is 1. So you're saying 5 goes into 11 one times.
No, it's gonna give it the reminder of 1.
Okay. So it's a remainder. So 5 goes into 11 twice.
And
2
the
fives
reminder
are
is
10,
1.
and there's 1 left over. So the remainder is 1. So modulus gives you what remains when you divide one number by another. So 11 modulus 5 is 1, because 5 fits in twice with 1 left over. Exponentiation?
I think that's to the power of 2.
Right, because earlier you said square root. So
I was confused, but I think it's to the power. Yeah, I wanted to say
to the power of. So num1 asterisk asterisk 2 is 11 to the power of 2. To the power of just simply means the number multiplied by itself the number of times that it says. So here we've got 11 asterisk asterisk 2, so it's 11 times 11, and we do that twice. If it had been 3 times, it would be 11 times 11 times 11, and so on. And floor division?
I think that would be then
square root. How many?
Yeah.
No, it's not square root.
How many times it divides by without the remainder?
So it's kind of the bit, as Jen says, that is kind of the opposite of modulus. So it's how many times it fits in. And you chuck it and you get rid of the remainder. So in this case, it's 11 / 4. So 4 goes into 11 twice, and there's a bit left over, and we're just getting rid of the remainder.
So do you just forget about the remainder, or do you like?
In this particular case, it's giving you a way to forget about the remainder, if that's what you want to do. So sometimes you want 11 divided by 4 to give you 2.8, whatever it's going to be. But sometimes you just want the 2. It depends what. Okay.
Okay. Yeah, thank you.
We have assignment operators, and we've already used the equal sign, which we are calling all in one
becomes.
Big becomes. Thank you. So num1 becomes 12. We have some others here. So plus equals, minus equals, asterisk equals, slash equals. What that says is take the number that you start with, in this case num1, and add 3 to it and put the result back into num1. So num1 becomes num1 plus 3. Num1 becomes num1 minus 5. Num1 becomes num1 times 2. Num1 becomes num1 divided by 4. Okay, so it's just a wee shorthand if you want to do that. And the reason I'm getting you to chorus becomes is because if you do want to say equals, is num1 the same as num2, then actually you use two equal signs. Is num1 the same as num2? Is num1 equals equals?
Sir, but when you type in equals equals to, does that not then print out whether this is true or false?
Yes. So the answer is Boolean. Is it true or not? So I can demonstrate that. So as well as answer, I'm going to print out okay, so we'll get some numbers. We'll run this. See, told you, I'll make mistakes. I didn't even mean to make that one. That was just being fast. Okay, so enter number 1, 8, enter number 2, 3, false. Num1 is not the same as num2. It's false. Try it again. Enter number 8, 8, true. Num1 is the same as num2.
Okay, so that's like a question to be answered by the computer in a way.
Yes, and what we're going to do in later weeks is start using those. So we're going to get questions answered. If age is less than 18, then charge for a child's ticket. Otherwise,
But then do we not need to, sorry to interrupt you, but do we not need to that in that case then type in the statement of if and then etc. etc.
yeah, so that's what I'm saying. We'll get to that later. We'll actually talk about, and they are actually if statements. So later on, we'll actually use these in if statements to make different things happen. So at the moment, I'm just saying these exist and this is what they are.
Perfect.
Okay, so there's is the same as, is not the same as, is greater than, is less than, is greater than or equal to, and is less than or equal to. Now, all of these things we've been talking about are for numbers. Sometimes it does and sometimes it doesn't make sense to talk about doing them with strings. Some do work, but they don't work maybe exactly the way you'd expect them to. So add and multiply do work, but they work slightly differently if you're using a string. So here we've got three strings: who let the dogs out and woof. So song title becomes string 1 plus string 2. So who let the dogs out? Print song title, and we've got who let the dogs out. First line becomes song title, which we've already calculated, plus 4 times string 3. So anyone want to guess what that's going to be?
It's going to print out string 3 4 times.
Before that,
So it's going to be like woof, woof, woof.
So it's going to print out the song title, who let the dogs out, woof, 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 woof.
Well, in the song it woofs 5 times, so that is wrong.
The operators.
Sorry, two people spoke there now.
Isn't it gonna print the operator multiply first before the addition?
Print the operator multiply first before the addition.
Yeah,
addition.
that's what I was thinking. Because no brackets.
BODMAS. That because he's saying about BODMAS, and see because the times is before, so it would be woof, 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 and then adding stuff.
Well, actually, that would work out the same way anyway, because you've then got a string that's woof, 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 and you add it to who let the dogs out. and then you print out that whole thing. So it works either
Would
way.
it put the woof 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 before the who let the dogs out or after?
They work slightly differently on strings.
I knew it was 5 times.
Is that true, Abby? Is that what that lyric is actually talking about? I didn't know that. Anyway, the point is you can concatenate strings. And do you want to know the etymology of concatenate? That's awful, Abby. I had no idea. I just thought it was dogs barking. I had no idea. That's terrible. So yeah, concatenate puts strings together, and the asterisk repeats the string. Casey, I don't think I even know the lyrics other than who let the dogs out, woof, woof, woof. And I'm probably not going to look them up now. So the plus is a concatenate, adds one to the end of the other, asterisk, multiple occurrences. So there's the question, what do you get if you do print 23 plus 16? Stick it in the chat. Nobody knows. 2316 says Nick. 2316 says Julia. Why isn't it 39? Thomas thinks it's 39. Thank goodness we've got some sensible people. Why does Thomas think it's 39? And the rest of
That's
you
the
think
answer. That's the answer of this equation, but the computer doesn't see it as such. It just sees it as two texts.
Yeah. So Thomas, sorry, you're wrong. Everyone else is right. You'll get 2316 because it's text. It's not a number. Even though we see it as numbers, even though in our head it's a number, even though we can't help thinking of it as a number, it's not. It's text. So again, make sure you know what type you're working with and what you expect to happen. Because if you don't know what you're expecting to come out, how are you going to check whether the program's working or not? Okay, so we've got a whole bunch of things that we can now do with numbers and strings. Not all of them by any means, but a whole bunch of them, including that kind of stuff. Remember that they go in BODMAS brackets of, so the asterisk is something to the power of, multiply and divide, and add and subtract. And when we're doing divide, we get that one as well. And anybody that was paying attention will tell you that the percent stands for. We did it about 3 slides ago.
Modulus.
It gives you the remainder
Modulus.
after you divide the number. Yeah, modulus.
Yep, remainder after divide. Thank you both.
I'm noticing that there's a lack of root. Like, what would that be?
We'll get to it in 2 or 3 weeks' time, but there's actually a built-in mathematical library that will give you square roots. And from memory, I think it's SQRT. But if you do a quick Google for Python square root, it'll tell you exactly what the function's called. I think SQRT. But as I'm telling you to do it, I might as well do it. So Python square root function. And you can see there that I was right, and it is SQRT. Okay, so if ever you're not sure, Google is your friend. Okay, so we do the order. Mod comes in at the same time as multiply and divide, which means we get different answers using the same numbers depending on where we put the brackets. Yeah, you're right. Do you know, I use Bing for you guys because I normally use Chrome, and I suddenly thought, I'm going to get this wrong and start showing you all my personal emails or something. So I'm using a different browser to show you guys stuff.
It's Microsoft Edge. It's awful.
Pardon?
It's Microsoft Edge, though. It's awful.
Oh, Edge, yeah, sorry. It's just because it's the only one I had installed at the time. Windows had decided to upgrade that day and put in Edge, and I'd never used it before. So I thought, I'll give it a go. And,
but I mean, Edge switched to Chromium anyway. So if you're calling Edge garbage, it's Chrome that you're calling garbage too.
Yeah, they all work in the same Chromium base. That's true. And anyway, yes, so I never get around to changing the default search to be Google rather than Bing. So that's why it's like that. So I wouldn't normally use Bing. I wouldn't normally use Edge. It's just so that I can look at what browser it is and know which one to go to quickly. For those of you of a mathematical bent, if you do want a square root, Jen has given you another option to do it in the chat, and you can work out for yourself why that works at some point. Right, any questions? No? Okay. So just like last time, we have a lab sheet. So I want you to go through the lab sheet, do the stuff in there. So many windows. Okay, so it's a few questions about data types, putting them into Python to check the work. There are some questions like this where it asks you what will happen. What I'd like you to do is try it before you type it in to see if you've got it in your head, but then type it in and see what happens. So more questions about variables, and finally writing a program and getting some input and putting out some responses. And again, that's on Teams just now. Questions? Is it on Aula? I have no idea. It's supposed to be on Aula. 2 hours ago was only
found nothing on Aula.
There you go. It's
I think we should disregard Aula at this point and just use Teams.
Yeah. Do me a favour, send that in an email to everybody that you know at the university. But don't tell them I said that. So no, it's not on Aula, but it is on Teams. So that's the lab for today. The same thing's going to apply. So we're at the end of the very long lecture. Sorry about that. And thank you for those people that said you enjoyed it anyway. It was probably more important for us to go through all the stuff and just go through it in detail than it was to try and finish at 1 o'clock after 1 hour. Because it means I get to show you more things rather than just telling you. So we might continue to do it that way, we'll see, but if we are going to go this way, I'll take more note of time in future and give you a break halfway, because thank you for saying you enjoyed it, but it probably is too long for us to be sitting, so I would definitely at least take a break. So, two things. We are going to go to the lab. Remember, that's a different meeting. It's 20 to 12. Don't go straight to the lab. Take a break. So I'm going to take 20 minutes. I'll be in the lab from noon if you want help. Before I go to the lab, what I'm going to do is I'm going to stop the recording. And if there's any questions that you want to ask without the recording, I'll hang about here for a few minutes. But other than that, thank you very much, and I shall see you in the lab in 20 minutes or so.
Thank you.
Thanks.